26 f of x equal to log of 18x minus x square minus 77. Eight x minus x square. What was that? 18x minus x square minus 77. 18x minus x square minus 77. Okay, and he's asked to find out the domain. Find, the question is domain. So
Yes.
this was very easy, easiest problem.
Yes, sir.
Actually, before going to solve this question, we will discuss some conceptual points which are belongs to the same type of this problem. Suppose if the function was given in the format of log f of x and base g of x. Of course, here the base is not a function. Base was not a function in this question, but in some questions it varies. And sometimes he will ask, he will give the problem which consists of the base is also a function of in terms of x's. So in general, we can take that problem in the format of log f of x base g of x. In such cases, we have to discuss three kinds of inequalities. The first one, f of x should be greater than 0.
Greater than 0.
And the second one is also g of x greater than 0. And the third condition, g of x not equal to 1. This is the conceptual point before we have to know while solving this kind of problems. So now take what is f of x and g of x. Clearly g of x, actually it was not 1 because it was 3 and it was not 1. And also g of x is more than 0 because we know that the real number 3 is always say more than 0. So there is no need of calculating this kind of two inequalities. Just the answer would depend upon the first inequality, that was f of x greater than 0. Actually here the f of x was clearly f of x was this one only. Okay, yeah. So we can take 18x minus x square minus 77, which was greater than 0. And I already told you the highest power of in the expression while we are dealing in inequalities, it should be always positive. So to make it x square positive, we should multiply with minus on either sides. Then it will become x square and minus 18x and plus 77 and should be less than 0. Okay, the inequality was changed. While why? Because we are multiplying with minus sign on both sides. Now we know that how to solve this quadratic expression x square minus 18x plus 77. Just take the quotient of x square and the constant, multiply it together. Both the product would be 77, and we have to split it into two factors. That's 77, and you can take 7 and 11 are the factors. And yeah, you can take both are negative values. So that we have x square minus 7x and minus 11x and plus 77 should be less than 0. That means where x is a common factor for these first two terms. So x, you can write x of x minus 7. After two terms, 11 is a common factor. So I'm considering here minus 11 is a common factor. Then I had x minus 7. Now, by observing these terms, x minus 7 is a common factor again for these two terms, and what left there, it would be x minus 11, which is entire the product would be less than 0. Now we can now have roots of these two factors. The first factor x minus 7 has a root 7, and the second factor x minus 11 has a root 11. Now take the real
Real
line
line.
which are having the ends minus infinity and plus infinity, and mark and locate the root values on increasing order. Actually, the root values are 7 and 11, so make them as an increasing order. And these factors, these roots, will change the entire real line into three parts. This is the first part, second part, and the third part. Okay. And it was asking which is less than 0. That means we have to, below 0 means
Should be
they are all
minus.
negatives. That means we are the required solution for less than 0. And we know that according to Wavy rule, this would be always positive, and alternately you have to change the signs, plus, minus, and plus. And we need here less than 0. That means the negative values. So the
So 7 to
answer would
11.
lies, yes, 7 less than x less than 11. That was the answer. That was the domain. So you can also write this expression as open interval 7 and 11. Okay.
Yes. Sir, I think this meeting is recording.
Yeah, I am recording the session. Do you have any problem?
No, 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 sir. I thought it was by mistake.
No. And 7 and
7, 11. First
says
option.
7 and 11. Yes, first option. 7 and 11. Yeah. We will do the problem number 27. The domain of log 5 base x. Problem number 27. Find the domain of log 5 base x. Log 5 base x. Okay. So let's compare the known result, that log f of x at base g of x. Here clear that f of x is a constant. It is always more than 0. Actually, there is no need for only we will discuss two situations.
Sir, I will do, sir, once.
Okay, do it yourself. Where f of x is 5, which was more than 0. Actually, there is no need of the condition 1. And we shall move to the condition number 2, which says that g of x greater than 0. And here g of x is x, and it was more than 0. That means more than 0 means you know that 0 to infinity, right?
Yeah.
According to this situation. And the third condition says g of x not equal to 1. That means x should not be equal to 1. So take the real line. It was the answer should be plus infinity and minus infinity, and mark the respective values. Actually, we have the numbers 0, 1, and a plus infinity. It was already marked here at the end of the right side. And the first value, according to the second inequality, it says from 0 onwards you can take any value up to infinity. That means you should take the open interval there, like this.
Yeah.
From open interval you can access any value up to infinity. And but this inequality says x is not equal to 1. That means you have to avoid the 1 from here, from the interval. So this expression, this answer should be represent as 0 to infinity minus 1 in this way, or you can also express this as or you can also express this situation as 0 to 1 union 1 to infinity. That means we are avoiding 1 from the solution set. Did you understand?
Yes, sir, yes.
So these are two ways we can express the answer. So let us cross check whether which option it contains. actually, yeah, r plus 2 minus 1. This
Sir,
was the
second.
answer. Because r plus means we know that r plus, that means positive reals. Positive real means 0 to infinity. That was r plus. Okay. And from r plus, we are avoiding single term 1. This was given as in that format. R plus 2, 0 to infinity, he expressed that as r plus. That means positive reals, and minus 1. So from real positive reals, we are avoiding the singleton set 1. That was the answer. Did you understand that? Okay.
Yes, sir.
Yeah. Next, try yourself. The problem 28. He said f of x equal mod x by 2 is a real function. Then f from R to B is a surjection. Surjection. Then B is equals to. Then B should be is equals to. Okay. Actually, the function was, so problem number 27. He defines f of x as mod x plus x by 2. Let us discuss some graphs regarding on the modulus functions. So suppose take this x-axis and it should be y-axis. Suppose mod x should be always like v type of function. Mod x is always v-shaped function. Okay, so this is mod x. Okay, if you do mod 2x, so mod 2x would be, this is mod 2x, modulus 2x. That means you can understand that if the multiple is raising, that means mod x and mod 2x, mod 3x, that means the graph is compressing itself towards the y-axis. Did you understand that?
Sir, can you explain again?
Actually, the graph, this is mod x, okay?
Yeah.
This is mod x. It should be in the V shape. And let us draw a graph with mod. This is mod 2x, and this is mod 3x, okay, and so on. So what is your observation? If you are raising the multiple of x whenever the function is modulus type, then the graph will be compressing. Okay.
Okay.
Yeah. Now, what about if we are doing submultiples? Then the graph would be enlarging like this, mod x by 2. And if you do also, then it would be mod x by 3. Okay, in this way we have the modulus graphs. Understood?
Okay. Yes, sir.
So now coming to the point. So now you can imagine that how the mod x by 2 graph would be. This one is mod x by 2. And he says f has a domain real number and the codomain would be what? Codomain would be b. It was the problem was given like that. Problem would be how much? Look at here, r and b. And he says surjection. What it means, surjection? Surjection means it's an onto function. Okay. Let's suppose consider two sets. This was A and this was B. According to the set A, we can name it 1, 1 or many 1. Okay.
Okay.
According to set B, we can say that it was onto or into. Okay. This was the nomenclature of the a function. 1, 1 means you know that What is a 1, 1? If 1, 2, 3 are elements, and here also take the same type of
Each
elements.
image.
Yeah, one element is connected to only one element for another set B. Then it was called 1, 1. Understood?
Yes, yes.
Okay. And many one means, suppose take 3 elements, same type of elements. Take 1 has image 1 and 2 has is also image 1 and 3 has image 2.
It will
And
be
here
subject.
in this configuration, you can understand that at least 2 elements have same image, then it is called many one. Understood?
Yes, sir.
Different elements have different images, then it was called 1, 1. And what about the onto and into? Look at the sets. Look at this figure. In this figure, actually, look at the set B. B has elements 1, 2, 3, and they are all connected to the elements of set A.
Setting.
That means it was called onto. This kind of situation is called onto. And now look at the second figure. Look at this figure. This figure, 1 has image 1, 2 has image 1, and 3 has image 2. Actually, in this set B, 3 has no pre-image, right?
Yeah.
This
Yes, okay.
situation is called into. This was
Okay.
into and this was onto. What you are understanding? Tell me. What you had understand?
If it is a one element to one element, it is on two. Then
Yes.
in here, if one element has two, it is into.
That onto is also called surjection. It
Yeah.
has two names,
Got it.
right? So onto is also called surjection. So now the mod x by 2 is onto, he says. That means actually mod x by 2, again I am drawing the same graph. So this was mod x by 2. What is the domain? The domain is real numbers, right?
Yeah.
So the domain, you can take all the x values on the entire x-axis, which is represented simply as capital R. That was the domain, okay? The red dotted shaded portion is a domain.
Okay.
Yeah, and codomain should be from here. We can, these values are called codomain. Actually, what is the codomain? Where can it access? It can access from 0 to plus
Plus
infinity.
infinity.
So B should be, and he says this function is, this function was onto or surjection. So B should be closer 0 to open infinity, right?
Yes.
Yeah, that was the set B. So this was the answer, closer 0 to infinity. Understood?
So can you explain this last part again? 0 to plus infinity.
Yes, sure. Actually, if f of x is equal to, that function was defined as mod x by 2.
Yeah.
Let us put x is equal to 0. Then we have f of 0, which was mod 0 by 2. And 0 by 2, you know, mod 0 and nothing but 0, because 0 is neither positive nor negative. That means in the graph, you should take like this. Understood? Because
Yes.
for 0, the functional value is also same, 0. Now take 1, okay, and also take minus 1, okay. So let us cross. So what it reflects, we will observe while in the calculations. So now put x equal to 1. That means f of 1. Can you substitute this value in the given function? So 1 by 2.
So
Modulus 1
1
by
plus
2.
1 plus 1 by
Yeah,
2.
modulus 0.5. Since it was a positive, you can take that directly as 0.5. That means if it was 1, somewhere here 0.5 lies for the value of x, right?
Yes.
This was the required point. Understood?
Yes. Yes.
For this
Yes.
value.
Okay.
Now again put x is equal to -1, which was the opposite direction. Now take x value as -1,
minus
then
1 by 2.
you have -1 by 2. Modulus,
Not
what will modulus do? Modulus will
positive.
do, yeah, it makes it positive. So it was 0.5. That
0.5.
means the same value we are having here. Now join these graph like this. Okay. In this way, we will have the graph like this.
Yeah.
That means which values are accessing on the y-axis is called codomain or set B. Which values
Yes.
are accessing from x-axis, that was called domain or set values of A. Understood?
Yes, sir.
The values of A are from the x-axis values. The values of B are from the y-axis values. He said surjection. That means no other
So,
values. Yeah, every value having pre-image in the set of A. That means the graph is accessing only the positive values. That means B should be always positive. That means B should be from 0 to infinity. That was the answer. Because look at, this is the least one. Except this 0, remaining all values are more than 0, and you can access up to the value of plus infinity. Understood? So
yes, sir.
the codomain, that was B, he said, according to given problem. So it would be B, and it said it is surjection or onto. That means every value of B has a pre-image, so that B should be always from 0 to infinity. And 0 was taken, so that I put a closed interval for 0. And we couldn't take the infinity, so I put the open interval for infinity. Understood?
Yes, sir.
Yeah, now try this problem. Next problem, problem number 29. Capital A equal to x slash x belongs to R and x is not equal to 0. The x values are from -4 to 4. And look at here. Here x is not 0 and x values are accessing from -4 to +4. In between of these -4 and 4, we have 0 also there, right? In between these values. And we should not take that 0. Okay. And the function is defined from the set A. Actually, the A was the domain. Okay. And R was real number system. And he said f of the function should be defined as mod x by x. This is called signum function. Okay.
Okay.
It is called signum function according to its definition. Not for every mod x by function is signum. Okay, understood?
Yes, sir.
Actually, if it was defined like +1 and -1 and 0, okay, mod x by x is called +1, 0, -1. When we get +1, if x is positive. When we get -1, if x is negative. When we get 0, if x equal to 0. Such case is called signum function.
Oh,
It is simply written as SIG of x. Okay.
okay.
Anywhere you can, if you found that SIG x, then in your memory you can flash the definition. Mod x by x, signum function of x is mod x by x, and it is +1 and -1 and 0. Okay.
Yes.
Actually, here it was not signum function because he didn't say anything about this function mod x by x, and simply he says for x belongs to A, and he already says x is not taking here, but signum function has the value for x equal 0. The signum value is also 0, right?
Yes.
But he told that
It is not
x is
equals.
not 0. Don't take the value 0 for x. So that it was not signum function. It's some kind of other function. And it was defined as mod x by x explained. So what is the range of this function? Clearly, it was very clear, right? It was
Yes,
-1 and
uncommon.
+1, right? There is no need
Yes.
of giving some solution because if x was positive, okay, I will tell you the solution also, no problem. So take that function, f of x is equal to mod x by x. So modulus function was defined as mod x is equal plus x whenever x is positive, and mod x is negative whenever x is negative. Understood?
Yes.
This is the definition for mod x. Here also we are using the same kind of definition. Write down mod x by x when it was happened if x is positive, and minus x by x when it was happened if x is negative. Did you understand that? What
Yes, sir.
changes I made here? The changes I made here for mod x only. For mod x only, I wrote if x
X
was
and Y.
positive, I wrote plus x instead of mod x. If x was negative, I wrote just minus x instead of mod x. Understood? According
Yes.
to the definition of mod x. So look at that values. Is there any cancellation possible here? Yes.
Oh, yes.
Yes. More x goes to x in one time for x greater than 0. X goes to x in one time, and there is also a minus 1. So for x is negative, we have minus 1. X is positive, we have plus 1. So it was clear that this was the range. This was the output for any value of x, because they are cancelling themselves, right?
Yes, sir.
So the range was plus 1 and minus 1. Okay.
Okay.
Is there any doubts?
No, sir. No.
Okay. Try to solve the next problem. Domain and range of mod x plus mod of x plus 1 are respectively. Problem number 30. F of x is equal to mod x plus modulus x plus 1. Is that was the function? Yes. Very, very easy. It was clear that you can take any value of x as a domain, right? You can take any value. That means domain should be, what is the domain? Real numbers. That means you can take any value as a value of x. Actually, there is no problem. We already told you in the synopsis. If f of x was given, simply say capital R is the domain, right? In our earlier sessions, we discussed this one. I will show you that. I made a table also there. Look at this function. What here I said? I said if f of x was given, okay, then it was real numbers. The domain would be real numbers. Okay, fine. Now, domain should be capital R. And now we are going to calculate the codomain or range. So for that, we have to make some graph for it. It was so much easy. So take x-axis and y-axis. Very, very simple. Take x-axis and y-axis. Okay, this was x dash and this was y dash and this was origin. Okay, did you understand that? Now tell me what are the roots for this one? What are the roots for this one? For getting roots, you should equate the inner part of modulus function to be 0. So what will happen here? X should be 0. That means 0 is the one of the root. And now here also do the same. Can you tell me what was the root for this function? So you have to take that internal part of the given function, which was x plus 1, and should equate it to 0 to get the root. So x is equal to how much? Minus 1. So that means these are the two root values. First of all, write down or mark them on the real axis. Okay. Now it was very easy. Okay, is it fine? So write down the given function first. Later make it equal to 0 to get the roots. The first root would be 0 and the second root would be -1. Fine. Now what is the thing here? Actually put x equal to 0 in the entire expression. Put x is equal to 0 in the entire expression. So what will happen? Mod 0, okay, plus mod 0 plus 1. How much? Mod 0 is 0, mod 1 is 1, that means 1 only. So for 0, the value should be 1, right? So make it a marking on it on y-axis. Later, what is the next root? -1. So now put in this value for x -1. So -1 under modulus plus modulus -1 plus 1. Okay. Did you understand this? So modulus -1 is how much? +1. And look at here, +1 -1 got cancelled. Modulus 0. Here also 1. So same point. Okay, join these 2 points. Okay, fine. Now tell me, take a random value somewhere here. I am taking 2 as a random value. In this direction, I took some -2. Okay, then we have the graph like this. It was raising and it is in the shape of V shape. We already know that mod x is always in the shape of V. According to our previous problem, we already discussed that. Mod x, modulus function is always, tell me what? Mod x is always a V-shaped function, okay? So here you have to raise the graph like this, and here also at the second end, you have to raise the graph like this. Did you understand this? Now tell me what is the range? A range means you know that the y values, right? So where the y values are accessed from 1 only, these values are accessing from up to infinity. The graph was made from the values of y. That means the codomain should be 1 to infinity. So from 1 to infinity, that was the range. Write down range is equal to closed 1 to infinity, because 1 is also accessible, so we put a closed interval on it. Okay, did you understand that?